What's up guys, this is Valuri Pavan and welcome to the second episode of MLITH Season 1. If you haven't watched the first episode, I highly recommend you to do so, and I'll add a card over here which will directly take you to the first episode. So what are we waiting for? Let's get started. Okay, so in the first episode, we covered three main learning problems, which is supervised, unsupervised and reinforcement learning. So from now on, we'll dive into the most important ones, which is supervised and unsupervised. For the record, most of the machine learning problems you'll encounter or you'll be given to tackle mostly lie between supervised or unsupervised learning problems. Remember, most, not all. So before we dive deep and lose ourselves in the world of machine and deep learning, it's always good to know what we are learning and see some applications of machine and deep learning in real life. So say you're a day trader and you want to invest in some particular company. You can build a machine learning or deep learning model that can predict the stock prices for you, so that you can get much more insights into what company to invest in. Or you can gather the stock news of that particular company and perform a sentiment analysis. And if the sentiment is positive, you're good to go. Amidst the COVID pandemic time, it's always important to wear a mask and maintain social distancing in public. So there were two projects that really rose to the top in the recent times. One is mask detection and the other is the social distancing detection. So both of these projects use computer vision to check if a person is wearing mask or not, and also if groups of people in public are maintaining social distancing or not. So what we just discussed is a classic example of computer vision. Computer vision is a massive field and it has wide variety of applications. And it's emerging so well, it's even being used in the area of medicine, where you use computer vision to detect cancerous cells and even detect pneumonia in chest x-rays. We'll be doing all these projects throughout this series. Machine learning and deep learning has vast applications in the area of natural language processing. Maybe you're doing sentiment analysis or neural machine translation to translate sentences from one language to another. NLP has picked up in the recent times due to the advances in deep learning technology. For one last example, if you've seen the channel intro, you would have seen Obama saying stuff which he would never say. That is known as a deep fake, though he would never say such stuff. Yes, deepfakes are a dangerous technology if used in a bad way, so make sure you only use it for education or research purposes, which is the main motto of this channel. So I hope that gives you enough motivation to dive deep into this world of machine learning and deep learning. So on to the drawing board.
Okay, so first, supervised learning. If you recall from the first episode, supervised learning is just learning the function that maps an input to an output based on some input-output pairs. For example, look at the table below. By just looking at the x and y values, can you predict the function that maps from x to y? Well, if you said y equal to 2x minus 1, then congratulations, you have just solved a supervised learning problem. And if I give you a new value of x, which I've never provided to you, you'll still be able to predict the value of y since you've already learned the function. So how do you do it? You would have looked at each input-output pair and tried to perform an educated guess to formulate a general rule that's satisfied for all points, right? Awesome. So what you just saw is a classic example of a regression problem. Another set of tasks we have in supervised learning is the classification problem. If you recall from the first episode, the dogs versus cats is a perfect example for classification. Let's dive deep into regression and see the different algorithms. First off, we have the linear regression. In linear regression, we try to map a function between two continuous variables. Here, in the scatter plot, we have the independent variable area in square feet and the dependent variable price. By intuition, we know that as the area increases, the price should also go up, which is depicted really well as a linear trend. Yes, there are points which do not follow an exact linear trend. It's because area isn't the only feature that affects the house price. Therefore, to handle multiple features, we have something known as a multiple linear regression, where we try to map a function between more than one independent variable. Next off, we have logistic regression. Yes, logistic regression is a classification algorithm, but we tend to place it under regression. It's because until the last step, basically we are doing regression. The last step involves converting the regression problem to a classification problem by applying an activation function and calculating something known as a decision boundary. And this decision boundary is used to separate the data into different classes. We'll get into this later. Next, we have the polynomial regression. Polynomial regression is an extension of linear regression to much complex non-linear trend in data. You get the idea? We also have lasso and ridge regression, and those are used to prevent overfitting in our model. We'll get to them later. Next, we have classification task. Under classification task, we have three primary categories: the binary classification, multi-class classification, and multi-label classification. Binary classification is basically distinguishing the data into two separate classes, unique classes. So basically, it's the dogs versus cats, or good, bad, or spam and ham. You get the idea. Multi-class classification is the extension of the concept of binary classification to more than two classes. So dog, cat, bird, good, bad, neutral. And multi-label classification is where you try to predict more than one class or one label for a given single data point. We have multiple algorithms for classification: logistic regression, naive Bayes, decision trees, support vector machines, k-nearest neighbors, random forest, and neural networks. Yes, it's vague to place neural networks under machine learning algorithms, but we'll just let them be there. Next off, we have the unsupervised learning problem. If you can recall, unsupervised learning is a learning problem where you do not need any labels associated with the input data. We have multiple algorithms. First off, we have clustering, where you try to group the input data based on patterns. Then you have anomaly detection, which is detecting suspicious or rare behavior that does not follow a particular pattern which the majority of the group does. Then we have neural networks. Yes, neural networks have a huge impact in the area of unsupervised learning. If you can look at the faces below, those are faces generated by a neural network. Maybe they're generated by a variational autoencoder or a generative adversarial network. If you do not understand the network architectures, don't worry about them. We'll get into every single one of them in detail. Next off, we have the latent variable models. We have the PCA and SVD. PCA basically converts higher dimensional data and brings them to lower dimensions so that you can visualize them and decide what to do with the data. So yeah, we covered a lot in today's video that probably you might not understand, and that's natural. It's because all we did today was give you the names of all algorithms present for each learning problem. So I'm just gonna go classic Andrew NG right now and say that if you don't understand, then don't worry about it. It's because you actually don't have to worry about it. And if you don't know who Andrew NG is, then you should Google it and check who he is. He's a legend in the area of machine and deep learning, and his courses are really amazing. So you guys, if you have time, just go check out his courses and try to do a few of them.
Okay, that's a lot of information to take in a single video, and it might be a little overwhelming too to know so many algorithms in one shot. The main point of this video was not to confuse you, but just to give you an understanding of how deep this area is, and just to make you well prepared for what we're going to be learning in the future episodes. So if you do not understand, you actually don't have to worry about it, because we'll cover every single algorithm we discussed in detail in the future episodes. Also, I'm happy to share that the second paper of our research team recently got published. It's still in preprint and it hasn't been reviewed yet, but then I'll add a link in the description and you can check out the paper if you guys are interested, and also the link to the GitHub repo. And yeah, in the next episode we are going to cover linear regression. So basically next episode is the starting point for actually diving deep into machine learning and getting ourselves prepared to tackle any machine learning problem we are offered. So make sure you don't miss out from the next episode. Thank you so much for watching this episode, and if you really like the video, then smash the like button and subscribe to the ML Veda if you already haven't, and turn on the notifications by hitting the bell icon. So see you guys in the next episode of MLITH Season 1. Keep learning.